Okay, I'm going to do one more here for Module 1, Lesson 4, second part of the review assignment. I'm a little limited. I don't have my whiteboard or my Promethean board, so I'm going to have to do this all on the keyboard, so you'll have to kind of bear with me here. We're supposed to write the equation for the inverse, so let's just go through the 4 steps. Right, the first step is we want to replace f of x with y. So we write this as y equals negative, oops, doesn't really matter, I guess put the negative in front. Negative could also go in the numerator, that would be fine. Negative 1/9 x minus 2. Okay, next step. Step 2 is to switch x and y. So that becomes a y and that becomes an x. And then step 3 is to isolate the new y. The new y will be our inverse relation. So to get the y by itself, think about what we've got to do. We've got to reverse order of operations. So any addition or subtraction, any loose addition or subtraction that's outside of parentheses, we have to undo first. So we have to undo subtracting 2 by adding 2 to both sides, which gets rid of the minus 2 on the right. Okay, now to get the y by itself, we have to undo multiplying by negative 1/9. Well, we know that to undo multiplying, we usually divide, but we don't divide by fractions. Instead, we multiply by their reciprocals. So we're going to multiply both sides, which means I have to put the left side in parentheses because I have to multiply the whole thing by the reciprocal of negative 1/9, which is negative 9. That gives me my answer, y equals negative 9 times the quantity x plus 2. And that's what I'm. And then the fourth step would be just to rewrite that as f inverse, but that's already done. I'm just filling in the blanks. Now notice this doesn't say to simplify, and so I don't need to distribute. I could write that as negative 9x minus 18, but I can just submit it like that and it's fine. Okay, next one, very similar. Do the same stuff. This time we'll go ahead and rewrite this in terms of y. Next step would be to switch x and y. Next step would be to solve for y. So once again, we're going to undo any loose addition or subtraction. In this case, we have to undo adding 8 by subtracting 8 from both sides. Now we're going to undo multiplying the y by 5/4 by multiplying both sides through by the reciprocal. So I've got to put that in parentheses. If I don't, it will be a mistake. The reciprocal of 5/4 is 4/5. And on this side, if I were to multiply by, I'll just show this once, if I were to multiply by 4/5, we can see that the 5s would cancel and the 4s would cancel. So they multiply to 1, as we know they have to, and that's my answer. Once again, I don't need to distribute because it doesn't say to simplify. Okay, this one's maybe just a little bit trickier. This time we've got a power function, and so we've got to, well, let's go through the steps. First step, rewrite it in terms of y. So y equals x to the 11th. And now we switch the x and the y. And now we've got to solve for y. Well, how do you undo taking something to the 11th power? We're just going to take the 11th root of both sides. The 11th root undoes the 11th power. I have to do the same thing to both sides. And so on the right side, the 11th root and the 11th power cancel, and I'm left with, oops, let's not do that. I'm just left with y. So that's my answer. Okay, very similar to the last one, only this time there's a little more to do. So let's write this in terms of y. Okay, we got to switch the x and the y again. And now, to isolate y, what are we going to do? We've got to first subtract 1/4 from both sides. So it goes away from the right side. Now I've got to divide both sides by -7. Okay, I could divide both sides by -7, but this time they want a simplified equation. There's a couple ways I could do this. I could divide by -7, but because I want it simplified, let's just go ahead and instead multiply each side by -1/7, because dividing by a number is the same as multiplying by 1 over that number. So if I do that, then I'm going to multiply the whole left side by -1/7. Realize that's the same thing as 1 over -7, but we never want to leave the negative sign in the denominator. We'd either want to put it out in front of the fraction or put it in the numerator. So multiplying each side by -1/7, which we can also think of as just multiplying by the reciprocal of -7, gets the y cubed by itself. And then just like before, to unlock the y from the y cubed, we're going to take a cube root of both sides, but that means the whole thing. So everything on the left side goes inside the radical. And that should do it. That's simplified because we're not dividing by a negative. I could distribute the -1/7 if I want to, but I don't think we're going to need to. I think, yep, it'll take it just like that. Okay, and then last, we've got one that's similar. So this time we start off with y equals x to the 10th minus 7. Now I'm going to add something else to this. I'm actually going to add the domain, because notice up here in the original problem, the domain is given to us as being x is greater than or equal to 0. So the domain has been restricted. We're told that is the domain of the function because that's what we said. That's how we defined it. So x is greater than or equal to 0. Okay, so just I know that's going to be read for a little while. It wouldn't like the format of that answer, but we're going to change it before we submit it anyway. So now we got to switch x and y. And we've got to solve for y. So what do I do to both sides? To get rid of the -7, I got to undo subtracting 7 by adding 7 to both sides. Gets rid of the 7 from the right side of the equation. Now I've got to undo taking y to the 10th power by taking a 10th root of both sides. But remember, when we isolate a variable by taking an even root, so a square root, which is a second root, or a fourth root, or a sixth root, or an eighth root, or a 10th root, or a 1000th root, it doesn't matter. If it's an even root of the function, then I have to, let's go through the steps here real quick. That undoes the y to the 10th and gives us a y. But remember that I've got to put a plus or minus out front then, right? Because whenever I take an even root of both sides of an equation, I've got to remember that's what we do for square roots, for example. So I've got to introduce that plus or minus. I don't even know if that's an option for it. Oh, there it is. Okay. And so that's my answer for y. But remember, when I switched the x and y, what did I not do? I didn't switch that original x in the domain to a y. So the domain of the original function up here becomes the range of the inverse. Well, if this tells me that y, which is really just f of x, needs to be greater than or equal to 0, then I can't keep the answer, the negative answer, in my plus or minus options. So I'm going to replace that plus or minus with just the positive answer. And so that's what I end up with.